A single phase transformer has a supply voltage of 225 volts, which is V1 is equal to 225 volts, and equivalent resistance of 0.38 ohms. Yabona, you're given equivalent resistance, and you're told it's referred to the what? Primary. That is why I'm putting one, which is 0.138 ohms. Then it and an equivalent leakage reactance. Okay, that is also referred to the what? Primary. So basically in this question we are referring to the primary. Okay, they have already calculated the equivalent resistance and the equivalent reactance of the transformer alone, internal. Sebezidibanisile internal, ne? Thetha equivalent internal, ne? Then but the secondary is connected to a what? A coil with a resistance of what? 200 ohms and a reactance of what? So in the share with secondary, the load. And because what we connect to the secondary is a what? Load. Yeah, okay. Because remember, the resistance and reactance that are in the secondary winding are only intended for only secondary winding. For example, the resistance, say already it was referred, and the reactance already was referred. Okay, so let us draw the circuit. Anna, R bani one equivalent, the equivalent resistance, meaning you have already combined. Okay, then okay, meaning we have already combined the reactance of the secondary coil, and we have already referred it to the what? Primary. Okay, into esishiyeke nayo kwi-secondary yintoni? I-load yethu ine-resistance ibe ne-coil. I-resistance ye-coil ngubani? Ngu-250 ohms. Then i-reactance ubani? 100 ohms. Bathi ke ngoku the secondary winding has 6 times as many as the primary winding. Okay, meaning that N2 is equals to bani 6 times N1. Bathi ke ngoku calculate what? Terminal voltage. Bafuna bani bona? V2. What is the formula to calculate terminal voltage? Besiyibhalile sithe bani? V2 is equals to bani? E2 open bracket 1 minus what? Per unit regulation. Okay. So guys, in order for me to get this terminal voltage, what do I need? I need the induced what? The induced what? Terminal voltage, and on yes, secondary. Then I need what? The per unit what? Regulation. I-induced voltage secondary is easy to calculate. So ndoqala ngayo so it is V1 over ibani 2 equals to n bani n1 over n2. Okay. So that is gonna be 225 25 over E2. Okay. Then N1 6 N money N1 because N2 kaloku in terms of N1 money 6 times N1. So this cancels that, this cancels that. So basically E2 ngubani? 2 5 times bani 6. And then oh 1 3 5 what? 0 volts. That is what? E2. Your boss is sorted. Yeah? Okay. What do I need next? Per unit what? Per unit regulation. I-power factor ixhomekeke kwintoni? Kwi-load. I-load yethu is what? Resistive and what? Inductive. So the power factor is what? Lagging. Na? So i-formula endizoyisebenzisa apha for i-power factor yeye-lagging. Yabo? You're sorry, not for i-power factor. I mean for intoni? Regulation. Yentoni? Yeye-lagging. And secondly, referring to the what? Primary what? Side. Anna? Okay. So, which is per unit reg is given by I bani I1 plus theta and primary. Na? Okay. The reason they were referring us to the primary, after that, if I was using the secondary, after that, yabo kuzoba nee-unknowns ezininzi or ii-formulas is what? As different. Kanti if we are referring to the primary, apha sinobani? Yi-one lo sinayo, na? Okay. Open bracket. Equivalent resistance of the transformer only. Okay. Not the load. You don't include the load here. Right? The equivalent resistance of the transformer only, na? Then bangibani? Cos theta. I-theta lo uxhomeke ntoni? Kwi-load because kaloku sithetha ngentoni? Nge-voltage regulation. I-voltage regulation ithetha ngentoni? Nge-output terminal what? Voltage, of which is yonke loo nto ixhomeke ntoni? Kwi-load. How much load is on the transformer? Right? The loading on the transformer determines the what? The voltage regulation. So plus x E1 sine yintoni endingenayo pha? I1. I have a problem with ubani? I1. To calculate I1, I1, if you also have a load on the what? On the secondary side, you must also include it to the primary side when you are calculating what? The current. That is I1, which is V1 over ZT. Okay. We must also account for this what? Load. Because a primary current is also dependent on the secondary current. Okay. So basically what we have to do now, we have to refer this load to what? To the primary side. To get money or ZT. So that's for money, the current. Okay. Because kaloku you also refer to reactance, secondary. You also refer to resistance secondary. Therefore, you must also refer the load so that uzokwazi uba le current of this whole what? Circuit. Because izokwazi uba the current of this whole circuit, na? Okay. Equivalent circuit. hammer. So we are left with nothing on the secondary side. Everything is reflected now. Okay. So guys, RT is equals to bani R plus R bani L referred to the what? Primary, né? Which is that is equals to RL because we don't have it in prime, né? So we convert it N1 over bani N2. If it was referring to the secondary, let's say N2 over bani N1. So RT is given by 0,38 plus RL ngubani ku RL ngubani ku 250 na, yes 250, then ngubani 1 over bani 6. Remember n1 bayathini they cancel, okay, because we expressed ubani n2 in terms of n1. Okay, izoba ngubani, sorry, 7,324 ohms. Yeah. Okay. Now we have to get what? What X bani? XT. XT izobang bani? XE1 plus XL prime, ane? Which is XE1 plus XL N1 over N bani 2 squared. Yeah? Then now guys, we can get OXT, which is what? 0,7 plus 100, nah? Open brackets 1 over bani 6 squared. Then xt bani or 3,538 ohms. Okay. Now that we got to RT, we can get to bani or Z bani, ZT go square root R bani T squared plus XL bani, your XT squared, which is 7,324 squared plus 3,538 squared. What is ZT? 8,134 ohms. Now we can calculate or I1. By calculating what I1, I can calculate now per unit reg. Once I get per unit reg, I can get the terminal voltage that by funayo, which is E2 open bracket minus per unit what? Regulation. Okay. So I1 is basically V1 over ZT. Huh? Okay. Okay. I1 is what? 225 and over ZT. What is ZT? Okay. I1 27, 662 amps. Guys, if you are calculating I2, now you would have to refer everything to one winding. Yeah, ma? Okay. Everything you refer to winding, kafuni current. Yeah, ma? Now we got money. I1, we can basically now, what we short of in one angle, ne? Detect that angle, the angle between the secondary what voltage and the the secondary terminal voltage, ne? And the current money I2, ne? Because remember, this thing you want it coming on the what? On the load. Yeah, well, so the angle to calculate the angle for a per unit regulation is 10, it's always 10, and then, okay, okay, is equals to x, and then, is it XL, RL? Guys, what is the voltage regulation we no load? At no load, the voltage, the per unit regulation is what? 0%, because i-voltage izophuma injalo ne ne i-voltage izolingana nantoni open circuit voltage i-terminal what voltage. Remember kaloku sithe E2 bani V2 over bani E2, these two are the same at what no load, izoba ngubani ngu-zero, hence sithi i-voltage regulation at no load is what is equals to 0. Okay, uh, let us find this angle. It's about 10. We always use this formula, ne? By L, sorry, sorry, 100 over 2, 250. Okay, 2, 21.801. Okay, and then, ah, okay, okay. Then we got the angle, which is gonna now going to calculate. It's about 27, 662, yeah. Then equivalent resistance referred to primary was 0, bani 38 cos 21, 801, and plus uh, equivalent reactance 0, 76 sine 21, 801 okay. Then a primary voltage about 225. The answers of mana we don't times by 100 because one per unit what reg. So one per unit regulation. But guys, I'm saying plus now because it's lagging. But you look at the load. The load has a resistance and a what? Inductor. If it had a capacitor, yeah, but yeah, mostly time is not really capacitive load. Guys, Tanzania, oh, ayikwazi ufaka yonke into. Okay. Okay, ke ngibani ke ukho? Sorry? Okay. Sorry? Cos, cos angle, ne? Pag cos ka. Ah, sorry. Boleh. Bye. So, so guys, it's 0,078 per unit value. Yeah, thank you. So V2 is basically what is E2 is 1,350 and open brackets 1 minus 0,078 what 8. Therefore, the output terminal voltage is 1. That is 1244.7 volts. That is 11 max.